Hello, what's cracking? Alright, so we're going to do an introduction to LU decomposition. So first let's start off with what that is. I know you probably don't want to hear this, but it is a lengthy method to solve system of equations. So there are several steps involved here to solve a system of equations. And also, I'll tell you what it's not. It's not an efficient by hand method. So this is something you'll probably do very few times by hand, and if you do get to use some sort of programming or a computer, that'd be great. But if you do have to do it by hand, I'll show you how to do that. So a very common situation is you'll have a system of equations that's 3 equations, and you'll have an unknown x, y, and z value, and then there will be known coefficients and these b values here. C1 to C9 is basically just different coefficients. B1 to B3 also just different numerical values. And then the first step is going to be to convert your system of equations to matrices. So I have that here. So all your coefficients, C1 to C9, is going to be a coefficient matrix A. Your x, y, and z value that's the solution vector x, which we want to solve for ultimately. And then you have your b vector over here, which is just the right-hand side of the equation. Okay, so looking at that right here, if you're to write this out, A will be a 3 by 3 matrix with all of the terms just as they appeared in the equation. And then your x solution vector is going to just be your x, y, and z value. This is the only part that is unknown. This is ultimately what we want to solve for. And then we have the b vector, which is just the right-hand side of the equation, and these are all known. These are all known, and this is the mystery. Okay, so our next step, number 2, is going to be find the U matrix, which stands for the upper matrix. And the way we're going to do that is we're going to start with our coefficient matrix A, and then we're going to apply these things called multiplication factors. So essentially what we're going to be doing is changing the rows of A and multiplying each row by a different value, and we're going to cancel out the first term of the second and third row and the second term of the third row with these different multiplication factors. So a little bit of clarification on what these multiplication factors are. So what we're going to do from row Alright, so a little bit of clarification on multiplication factors. What we're going to do is multiply row 1 by your first multiplication factor, MF1, and that's going to cancel out the first term in the second row of the A matrix. And then we're also going to do the same thing, multiply row 1 by multiplication factor number 2, and that'll cancel out the first term in the third row of the A matrix. And then finally, for row 2, we're going to multiply by multiplication factor 3, and this will cancel out the second term in the third row of the A matrix. So while the upper matrix is just consists of terms along the diagonal and above it, so we found that the L, or the lower matrix, consists of ones along the diagonal, zeros above it, and the multiplication factors below that. So the multiplication factors you used on row A, the multiplication factors you used on matrix A to cancel out the lower. So the multiplication factors you used on matrix A to get the upper matrix, those will then be substituted into the lower matrix here, as you can see, MF1, MF2, MF3. All right, and then the next step is to verify that we have the right lower and upper matrix. So verify that L times U equals our coefficient matrix A. And if you verify that and it works out using linear algebra, then you know that you found the right L and U matrices. Okay? So if finding the L matrix was our third step, verifying was our fourth step, and that brings us to our fifth step, which is to find the vector D. So if we already have our L matrix from above, and we also have our B vector, which is just the right-hand side of the equation, then what we need to do is solve for D. And what D is it's a vector which will consist of three terms, D1, D2, and D3, and you're going to simply multiply this by the terms in L, set that equal to the terms in B, and you'll solve individually for D3, D2, and D1. Alright, so the sixth and final step is to find the solution vector x. So once we have D, we'll be able to find the solution vector x, which is what we've all been waiting for. That's what our ultimate goal is. So once we get our D vector, remember we have our L and we have our B. We'll plug that D vector into here, and since we now have our D vector and our U matrix, we can finally solve our for x vector, which is our solution vector. And if you'll recall, that's x, y, z, and you'll be able to solve for what z equals, what y equals, and what x equals. And you'll be able to finally, step 7, verify the system of equations by plugging in x, y, and z. Alright, once again, thanks for watching. I hope this was somewhat helpful, but the most helpful thing for you is going to be not memorizing these steps, but actually using these steps. Alright, once again, thanks for watching. I hope you watched all the steps and have a good understanding. The most useful thing to you will be not memorizing these steps, but using these guidelines I provided and going through a few problems so that you understand the procedure to finally find the solution vector x. Alright, thanks for watching.